Okay, so welcome to our second video on strings here for Visual Basic 2010. So far we've taken a look at the L case and the U case functions. We also looked at our string conversion function here using our VB proper case, for instance. We also looked at the left and right functions. And we showed you the alternate ways to set those up for VB10. We also looked at our mid function there. Okay, and we also worked through the mid statement, of course. And finally, we finished the last video with the len function. Okay, so in this second part of the video, we're going to take a look at the instr function. So it's a built-in Visual Basic function that returns the starting position of a substring. And a substring is basically simply a portion of a string. So the syntax for this function is, so in string, instr, bracket, start, comma, string 1, comma, string 2. Where start is the position in string 1 to start searching. If start is not included, searching automatically begins at position 1 by default. String 1 is a string variable, or string enclosed in quotation marks, that will be searched. String 2 is also a string variable, or string enclosed in quotation marks, that will be searched for. So the following code demonstrates this function. So we can dim our str month as a string, and then we'll do another one here on the same line because we can do that as well, as you know, comma str substring as a string. Okay, and then dim int start as integer, and we're going to set up our str month is equal to quote unquote January, and we'll have our substring is equal to AR, and our int start is equal to 3. So in this code here, it's going to start at, well, we'll see what it's going to do. So the label will display the return value 5 as the substring begins at position 5. The search began at position 3. So we're looking for AR in January, right? 1, 2, 3, 4, 5. So that's where the substring begins at position 5, okay? And they began the search at position 1. So let's just see this in Visual Basic to see if it makes sense to us. Okay, so I've gone ahead and set up that code here in our VB. Really basic form we have set up with the label here. And here's our code. So we do our dim statements for string and str month, str substring, ntr start as integer. So the month is January, the substring is AR, which is the latter part here. And we're starting at position 3, so 1, 2, 3. It's going to start searching there. So if I hit run, in the label, the answer is going to be 5. Okay, it's going to be 5. Let's just play around with this start position just for fun, see if it affects anything. Run this again, still is going to be 5. Okay, what happens if I change this to RY? What do you think? Okay, well, it's going to be 6. Okay, so that's the position it's at. So 1, 2, 3, 4, 5, 6. And that should make sense if I change it to J. Now, what do you think is going to happen? Anything? 0. So it doesn't even work because we're starting at position 2, 1, 2. So therefore, it's not even going to work. So if I set this to A, what do you think will happen? Position 2. So it starts at 2, but does it include 2? 1, 2, 3. Okay, so something to think about there as we go along in this, okay? So let's go back and take a look as we move along. Okay, so this is an extended example. So in this example, the label will display the value 5 as we looked. Okay, a start position was not indicated, so search began at 1 by default. So we don't always have to indicate a starting position. Okay, it's not something we have to do. In the final example, we can see here month and string January and AN, int start at 4. So, and I just showed an example very similar to that. The label displays 0 because the substring is never found. The start position was 4, so JANU, so it started at U. And the substring appears before position 4. If a substring is not found, Visual Basic returns 0 by default. So that explains what happened prior to, I already showed that sort of example. Okay, so generating strings. In this lesson, we will look at Visual Basic built-in string functions that allow us to generate strings. And these include string, space, ampersand operator, VB tab, VB CRLF. So the string function. The string function is a built-in Visual Basic function that returns a string of repeating characters. The syntax for this is string, bracket, integer, comma, character, where integer is an integer variable or value indicating the number of characters in the returned string, and the character is a character enclosed in quotation marks to be used for the string. So the following code demonstrates the use of the string function. So we set up a variable in str horizontal rule as string. Str horizontal rule is equal to, and here is the interesting piece of the code in the red, string bracket 20 comma quote star quote, and then we close our bracket. What this is going to do is print 20 of these asterisks or these stars. So let's see it in real time in VB. So as we see here, this is Visual Basic 6 again. So our code is going to slightly be a little bit different. So instead of the red here, we're going to type in this. So we're going to set the string horizontal rule equal to new string bracket quote asterisk bracket or quote comma 20. Okay, and you'll be able to see if I run this, it puts those 20 asterisk stars in a row in my label. Perfect. So that's how we can generate a string pretty simply. Okay. So let's keep looking at this. The space function is the Visual Basic built-in function that returns a string of spaces. Okay, so that might be helppful. Where integer is an integer variable or value indicating the number of spaces in the returned string. Okay, and again here we want to put in this string and this label 20 blank spaces. Here's a look at our code. And let's take a look at it in Visual Basic. And taking a look here at our program and the code here in VB. So we created a dim for str blanks as a string, and we just simply say the code is that simple: space, bracket, 20, bracket. We can make that any number we want. It could be 1, it could be 1,000. And then in our LBL label, the text is going to be equal to that string. Hit run. Oh wow, nothing is there. Just to make it more tangible, make a little bit more sense. Watch what I'll do here. I'm going to put in the words HE. Okay. I'm going to add. I want to put the word hello and just show you that the blank does show up in the middle. So here I have HE and our 20 blank spaces and then hello. There we go. So if I run this, check it out. Okay, see, that makes more sense, I think. So that's an example how we can use the space function in Visual Basic. Okay, let's move on here. So our string concatenation. The ampersand operator is used to join two or more strings into one string. And the syntax for the use of the operator is as follows. So we have string is equal to string 1 and string 2. Okay, where they're both variables. Okay. So I kind of just showed that off, didn't I, actually, in my last example. But let's take a look at this more thorough code and see how it looks in VB. So we have several strings here to find. Okay, so 1, 2, 3, 4 different strings. Okay, and then we're going to have the words tick and tack and toe, and we're going to put them all together. And then we can actually add spaces between it. Look at that. It's pretty neat. We can put that right inside of our code. So let me show you how that looks on Visual Basic as well. Okay, so now we can look at our Visual Basic program here. I just dimmed mine all as one big long dim. So first word, second word, third word, and the phrase, all the strings. I set the first word to tick, second word to tack, and the third word to toe. And if you take a look at the phrase, I set that equal to first word, ampersand, second word, ampersand, third word. And then in my label, I'm going to just simply print out the phrase. And then when we run it, we can say, hey, okay, well, that's cool, but well, it is jammed together and it doesn't look very good, when we're reading it as plain English. So what we can do is go ahead and add a space between the words using this bit of coding. And all we're doing is adding in spacing with our Visual Basic. So we'll show you what that looks like. Okay, so what I've done here is added a second label, and I said the text is going to be equal to the string first word and a space, another second word and a space, and a third word and a space. If I run that, we see the original all crammed together, and the second one nicely formatted, and it looks a lot better. Now, a little workaround and or hack or whatever you want to think of it as, we could also basically do this. Okay, now you see what I did here. I inserted just a blank space, and that actually has the exact same effect. So there's a couple different ways to do it. One is quicker and better than the other. It doesn't matter, but it is good to know this space function for sure. Okay, so let's take a look here at generating strings. Okay, we've done all these things. So the VB tab and VB CRLF functions, two constants that are useful with strings are VB tab and VB CRLF. The VB tab represents the tab character on our keyboard in the top left corner, which represents 8 blank spaces or indenting. We might know that from Microsoft Word. VBCRLF represents a carriage return line feed combination used to move text to the next line. So the following example, message box, 1 step, ampersand VB tab, ampersand forward, ampersand VBCRLF, ampersand 2 steps back. We'll show you the following string in a message box. Okay, so across it's going to have 1 step and then our VB tab, so 8 blank spaces forward. And then on the next line, it's going to come out 2 steps back. I'm not going to show you that in VB. That's pretty straightforward, I think, for us to visualize. Now we're going to look at comparing strings. So recall from earlier units that computers can only store numerical data stored in memory as bytes. Each byte is made up of 8 bits. Each bit is either on or off. When a bit is on, it is said to store 1. When it's off, it stores a 0. The 1s and 0s stored by a computer represent the binary number system. Also recall that when a character, such as a letter of the alphabet, needs to be stored in memory, it is stored as a number. The ASCII code represents characters as numbers. Strings, which are strings of characters, can be compared, for example, to determine if one string is the same as another string, or to see if one string comes alphabetically before or after another. If we use relational operators, equal to, greater than, less than, equal to, greater than, equal to, not equal to, for making these comparisons, we would use the internal binary representation of the characters to determine their relationship. Okay? For example, uppercase B less than lowercase a would be true because an uppercase b is represented in ASCII by the number 66, and the lowercase representation for a is 97. So again, it's going to come back to numbers in some ways, but you'll come to better understand that as we go along. So Visual Basic has built-in functions that allow us to perform textual comparisons on strings. A textual comparison is a comparison that does not distinguish between uppercase and lowercase letters. 2 ways to perform textual comparisons are to use the strcomp function with the VB text compare constant or the like operator. Okay, so the strcomp function, the syntax for this function is strcomp string 1, string 2 compare, where string 1 and string 2 are strings, variables are string enclosed within quotations. Compare is the Visual Basic constant VB text compare used to indicate a textual comparison. String 1 will return 0 if the string 1 and string 2 are textually equal. String comp will return -1 if string 1 is less than string 2. And when string 1 is greater than string 2, a 1 will be returned. Okay? So we can go ahead and continue looking on here. Our comparing strings. The like operator can also be used to perform textual comparisons on strings. Like is usually used to perform pattern matching. For example, you may wish to look for strings that all end with the pattern, and we see here in quotations and a asterisk ION. In this example, the asterisk is a wildcard, and hopefully you know a little bit about this from maybe Google searching or searching for articles online. That replaces characters, and ion is the pattern you're looking for. So the asterisk could stand for just about anything. So the syntax for comparisons using the like operator is shown. So pattern matching allows for the use of wildcard characters, character list, and character ranges to compare strings as shown in the table below. Okay, so result is equal to string like pattern, where result is Boolean or integer variable that will store the result of the expression using like. Result will be true if string matches, otherwise it's false. String is a string variable or a string enclosed in quotation marks, and pattern can be in many forms, each of which is shown in the chart below. Here's the different wildcards. Okay, you should look these over and understand what they mean. Okay. Question marks used in place of any single character, or asterisk is used in place of many characters. Number sign is used in place of any single number. Okay. our square brackets used to enclose a list of characters. Dash is used to indicate a range of characters. Okay, and a comma used to separate characters. So look these over and make sense of them. It's very important. Okay. So what we're going to do is, well, you should finish this by wrapping up, reading through this thoroughly and taking a look. We'll pull up a piece of code just to show off some of these right now and take a look at the string comp function. Okay, so we're going to take a look at the string comp function right here. So I've just kept with our tic-tac-toe example and just switched around a couple things and made the first word A and the second word B. So what I can do is str comp. Okay, just like we looked here, and then we could compare them. Okay, so what we can do, rather, sorry about that, is we're going to run this right now. So A, B, and what's going to happen in my first label box is going to be a -1. So -1, string comp will return -1 if string 1 is less than string 2. Let's make them the same, B and B. Okay, let's run that, and that gives us a 0. So what does 0 mean? When string comp will return 0 if string 1 and string 2 are textually equal. And let's switch this to B and then A. And run that, and it comes out as 1, which is when string 1 is greater than string 2, a 1 is returned. Okay? And now taking a look at our like function here in Visual Basic. So in this text box, I'm going to have compare is string, string, like or similar to string. Well, and if it's a Boolean, it should come back as what? True, and it does indeed. If I take a word out, what's going to happen? It's going to come up as false. Now, I'll try it again using, we said we can use a question mark or an asterisk that used in place of a single character or many. So right now I'm taking out the word S and I'm just replacing it with that. Should we come up as true? It does indeed. Okay, and now I'll try it with the asterisk. And it should give us the same result, and it is true for sure. I could change it around. Let's try another iteration. And this time I put in str first, then the asterisk. And because that asterisk can represent multiple characters, it's going to come back as true. What do you think if I use the question mark, however? Let's give it a shot. And you see it comes back as false because our question mark only represents one single character. So that just about wraps up that portion of the chapter, the text on strings. So hopefully you have a chance to go through this, play with them a bit more, and see how these might be applicable to other parts of programming in Visual Basic.